That's going fine.
Okay, what chapter are you on?
We're on parallel lines, chapter 3, I think.
Okay.
Parallel lines and angles.
Now, you're still going to be doing proofs with perpendicular and parallel lines.
Oh, I got a 90 on my proofs test, by the way.
Well, very good.
Yeah.
Fantastic. Yeah. So you're not quite done with proofs because there's a lot of proofs in chapter 3.
All right.
So if you need to go over any of them, let me know. In other words, if you're having any questions whatsoever, the only person that can tell me that is you. And I need you to do that. I don't want you to keep letting me dictate. I noticed that in chapter 3.2, proof and perpendicular lines, there's a lot of cool proofs where they give you both columns. And then there's a couple of proofs where they give you one column only for each row. And those are the ones I think are actually most useful. For example, number 19. It's on my page 140 on perpendicular and parallel lines. And it's got 7 rows, and 3 of the statements are filled in, and 4 of the reasons are filled in. Actually, 5 of the reasons. And you have to fill in the missing thing. To me, that's the most effective way to learn how to really write a full 2-column proof from beginning to end. And let me just say a thing about parallel lines and transversals. They have 4 theorems. And I've always kind of disagreed with this, but they teach you that 3 equals 4, right? And they call that the alternate interior angles. And they teach you that 5 and 4 are supplementary because they are consecutive interior angles. Interior basically means between the parallel lines. Anything that's between the parallel lines is interior. And then they give you a 3rd theorem that says that angle 1 equals angle 8, and they call that alternate exterior angles. Exterior because it's outside of the 2 parallel lines. And then finally they give you the perpendicular transversal, which is where if you have a perpendicular transversal, if it's perpendicular there, it's perpendicular in all 8 spots. In other words, they come up with 4 different theorems to say the same thing. The problem is you're going to have to know all 4 of them. You're going to have to know what an alternate exterior, you want to know what consecutive angles are, you want to know what corresponding angles are. Not quite sure why they go out of their way to be so complicated, because to me it's a question of you create 2 angles and every angle you see is either 1 or 2. And it's pretty easy to tell which it is. You just look at the obtuse or you look at the acute. But if you're doing a geometric proof and you're trying to prove that 2 is equal to 6, you have to cite the proper theorem. Or let's say you're trying to prove that 3 is equal to 6. then you would use the alternate interior angle theorem. Okay? In other words, they don't just have one theorem, which it seems like they should. They have 4 different theorems that relate all 8 of these angles. The thing about theorems is you don't really have to memorize. I mean, you may have to for your geometry class, but for long-term geometry, you don't have to know what the theorem is called, and you don't even have to know that it exists, as long as you know what the outcome is. In other words, as long as you know that angle 1 is equal to angle 7, it doesn't matter if you know the theorem or not. It's important that you know those are equal.
Mm-hmm.
Well, I've already talked to you quite a bit about parallel lines, so I would think that you're probably not having too much difficulty in Chapter 3. The only difficulties might be the proofs. And they have a number of good proofs in Chapter 3 regarding parallel lines. But if you are telling me you're totally on top of it, let's not spend any more time on that, and let's go back and finish up our geometry basics, the thing we've been working on. And some of this stuff is probably stuff like solids. You might not get that for 2 or 3 months. Okay? Mm-hmm. So, but that's okay. When you do get it, you'll be much better prepared for it, having gone through it once. Maybe what I'll try to do in the future is, as soon as I finish this test here, what I'll do is try to stay ahead of you in the book. In other words, if you're on Chapter 3 and you're really comfortable with Chapter 3, then I'll work on Chapter 4. And that would be ideal. It's always good to have a little bit. It's much, much better to be ahead than it is behind.
Yeah, I agree.
All right. So here we're talking about volumes. Volumes of a cylinder. Soup can. What's the volume of that cylinder, do you know? The general volume of a cylinder?
Diameter times height?
Well, no. It's a prism. Okay? And a prism is defined as having 2 equal, opposite, and parallel bases. In other words, this circle at the bottom is the same area as this circle at the top. And it's a prism because if I were to slice across it at any point horizontally, I would see a circle. In other words, that's a prism. This is also a prism. Why? Because you have the same area of this rectangle or square, and it's equal to that, and everything in between it, if I were to slice across it, I would see a square. So anything that's like that is called a prism. And the volume of all prisms is the area of the base, which is generally, they use a capital B for that, times the height. Okay? And it's important that you distinguish between capital B and little b. If I say, what's the area of a rectangle, and you say, well, it's base times height, this base is one-dimensional. It would be measured in inches or feet or meters or something like that.
Capital letters for multiple dimensions.
Yeah, this B is measured in square inches or square meters. It's not a one-dimensional thing. So I'm even hesitant to use the letter B because people get it confused with the small b. But as long as you know the difference between small and capital, we can use it. Well, the volume of our cylinder has to be a right cylinder. What's the area of the circular base?
Pi r squared.
So there's the volume of a cylinder, prism. Okay. Now, the question says, what's the ratio of a volume of a cylinder with radius r and height r, which is this right here, compared to the volume of a cylinder with radius h and height r? Well, that cylinder would be what? In other words, the second one they're talking about. One that has a radius of h and a height of r. So, in place of the r, I'm going to stick h. And in place of the h, I'm going to stick r.
All right.
Now what they want is that ratio. What's that ratio? This is just an algebra problem at this point.
So cancel the pi's. So
Okay.
cancel the squares.
No, that's an r squared. This is an h squared.
Okay.
However, you can do something with the r squared divided by r. What does that equal to?
R.
In the numerator. And how about the h divided by h squared?
H.
In the denominator.
All right.
Okay. In other words, when you do the h's, you can look at it a number of ways. You can look at it as h to the 1 divided by h to the 2, which means you subtract the exponents, so you get h to the minus 1, and h to the minus 1 is 1 over h. Okay? And the same thing with the r's, but that's how you end up precisely with r over h. So there's your answer.
All right.
A cube and a rectangular solid are equal in volume. Well, let's see what they mean by that. I apologize for not being a very good artist. There's my rectangular solid. There's my cube. And the volumes are equal. So that's the volume of the rectangular solid. That's the volume of the cube. Let's make the rectangular solid x, y, z. Those are its 3 dimensions. The one thing we know about a rectangular solid is that all the angles are right angles. And it can have 3 different dimensions. It's kind of what I call a rectangular brick. Okay? Whereas a cube only has one dimension. They're all the same. It's x, x, and x. Okay, so they give us the three dimensions of the rectangular solid. Let's write them in there. And it's 4, 8, and 16. And the dimensions of the cube is what we're solving for. So first of all, what is the volume of the rectangular solid? How can I get it?
Base times length times height.
Okay, good. So it's 4 times 8 times 16. Let's see. Here, I have a calculator here. $512. So the volume of the rectangular solid is 512. So how do I solve for x? If I know the volume of the cube is also 512, because that's what they said, they have equal volumes, what's the formula for the volume of the cube?
Cube root of 512.
Well, let's start one step at a time. What's the volume of the cube?
512.
Well, okay. What's the general volume based on that model right there?
Length times width times height. So
which is, in this case, what?
X times x times x, or x cubed.
X cubed. That's what I was trying to get at. Okay? Because we're trying to solve for x. So we can replace the volume of the cube with the number 512, and that's equal to x cubed. And now, all we need to do is find the cube root of 512, and we have x. And that's 6?
8.
8. Okay, cool. So it's equal 8. All right. When 16 cubic meters of water are poured into an empty cubic container being the key words, it's not a rectangular brick, it's a cube. All sides are the same. It fills the container to 25% of its capacity. What is the length of one edge of the container in meters?
So 16 is 25%. You can multiply it by 4.
Okay. So
Volume.
64 would be what? The volume of the cube, right?
Mm-hmm.
What's the length of one edge?
You can cube root.
Good. What's the cube root of 64? That's a good one to memorize.
4.
Uh-huh. So it has to be 4 by 4 by 4. That would give it a volume of 64, 25% of which would be 16.
Mm-hmm.
All right. Let's do this one here. Now, notice that this is, what is this called? The shape?
Triangular prism?
Yeah, it's a prism, first of all. I mean, it's triangular because the parallel bases are both triangles. But mainly it's a prism. In other words, if you were to slice it anywhere in between, you would see a triangle. So it's basically the same triangle on this end as it is on this end, and you merely have a thickness in between. So what would the volume of that prism be? be? Remember, the volume of a prism is the area of the base times, we call it height, but what we really mean is the thickness between the two bases.
Mm-hmm. Hypotenuse of the triangles is 4 times the square root of 2.
And it's half of a cube.
Yeah.
So what does that mean about each triangle? In other words, ultimately we have to figure out the area of this triangle.
Mm-hmm.
What are these angles if that's half of a cube? What are 1 and 2?
45 degrees.
Yeah, they have to be. And that's critical to solving it. Because you're going to have to figure out what this dimension is and what this dimension is. What are they? Based on your knowledge of this special triangle. Never forget these two triangles. It's easy, but I'm not going to let you forget them.
5.
Well, what are the dimensions? 1, 1, and root 2, right?
Yeah.
So if we're looking at 4 root 2, what are the dimensions of the two sides?
4 and 4.
Yeah. In other words, the similarity ratio is 4 to 1. So each side has to be 4 times the other sides. Now, what's the volume of the solid of this solid? In other words, first of all, figure out the base of the triangle. What's that?
4.
What's the area?
I'm sorry. So 6, 8.
Okay. So the area of the base is 8, and that's in square whatever. They don't have a units, but it's either square inches or square meters. What's the thickness? In other words, what's this dimension here? That's h.
Oh, if it's half a cube, wouldn't it just be 4?
Exactly. So 32 is the volume of that solid. And really the key to this problem was figuring out what the sides of each one was. And that really is figuring out that triangle, that 45-45 triangle. Remember, you're going to run into that 100 times. All right, we don't need to get started on a new one. We can stop here. So one last thing before I let you go. Tell me the dimensions of the 30-60 triangle. It's the opposite to the 30. What's opposite of 30?
3.
I call these my unit special triangles. There's a reason I use the word unit.
1.
Always. Opposite the smallest is 1. Remember the 45-45? That was 1, 1, square root of 2. So always remember in both of these that the smallest angle opposite it is 1. Now what's opposite the 60? And this is the one that's tough to remember.
2 or 3?
Remember, it's different than this number. In other words, if you consider these in unison, we have a 1, a 2, and a 3. So remember, you need a 3. And the only place for a 3 is going to be down here. Okay? So always remember those, because the problems you're going to be constantly be presented with is solving triangles that are similar to this. You know, I mean, if I tell you that I have a 30-60 that has a hypotenuse of 6, you know that it's 3 times that, so that has to be 3, and that has to be 3 root 3. So memorize these two triangles.
All right.
All right, Cole, I will talk to you next Monday. You have a good week.
You too.